I'm not sure who's on here. I think we've had 3 people register, and I know that we also have had another parent and student join in, and I don't know who else is listening, but welcome to this live webinar to discuss fractional understanding, getting a deep conceptual understanding of fractions. And with me tonight I have Heather Dooling, who teaches at Deer Meadow School in Old Alberta, grade 7.
Yep.
And for those of you who don't know me, of course, I'm Darlene Cusick, the lady who lives, breathes, and sleeps mathematics, as you know. And if you want to learn more about me and more about what I do, you can get onto my website at www.mathforsuccess.org. I'm going to get started here, and there's what I'm looking at, and the intent of this webinar is to kind of put Heather on the spot a little bit, but she's been given the questions prior, so I want to talk to her about the grade 7 struggles with regards to fractional, deep fractional understanding, and you can share what your curriculum outcomes are at that level and where those struggles are, Heather, and then the reasons why you think that those struggles are there. What are the reasons that you think those struggles are there? And then I'm going to talk to you a little bit about the progression about understanding fractions. And if students are struggling at the ages of grade 5, 6, 7, and 8, we often have to backtrack to that start. So that's kind of what I want to just talk to you a little bit about that progression. So I'm going to hand over that floor to you and give you a few minutes to just talk about those struggles and what do you think the reasons for them are.
Okay. So with our grade 7 curriculum, we learn about equivalent fractions, comparing and ordering, adding and subtracting fractions. So that's where I'm coming from grade 7. The struggles that I see with them are understanding right back to what is a fraction exactly. So in order to learn how we can make those equivalent or how we can add them, we need to go back to what exactly is a fraction. Okay, so we go right back to that initial learning. And they seem to get it at the beginning. We use lots of manipulatives, so the circles and the foam pieces when we look at different shapes, different sizes of fractions or different numbers in the whole. And then it seems like they understand, but once we get into the adding and the subtracting and having to have that denominator the same, it's just like, oh, I'm not, they get stumped. So for me, I think it's going back to 1/4. We're not going to add to 3/7, right? To try to make that denominator the same so that the number of pieces in that whole are the same. And it seems to be a struggle with each class.
Can I ask you, I'm just writing some notes down as you're talking because these are things that I'm reading about and I'm learning about. And actually fractions have just become something that I want to eat up. Well, I eat up everything about math, but it's something I struggled with in school too. Yeah. And as I'm learning more about it, I'm like, aha, I'm having those aha moments. And even when I've been working with my grade 3s in the last few years, you go back and you ask, what is a fraction? And you think they get it. What are they answering you?
They're answering me parts of a whole.
Okay, that's not a fraction.
Yeah.
That's not the meaning of a fraction. A fraction is actually a number, and I'm not going to get into, I want to see what you think the reasons are for, and that's what we're going to talk about. So they're really not understanding the deep meaning of what a fraction
what that concept is,
okay?
Right? Yeah.
Now when you say you're taking out manipulatives and models, what kind of manipulatives and models are you using?
We have used, it's primarily with, when we do our equivalent fractions, it's the fraction foam circles with the pieces. So the red one has 2 or whatever in the that, and we've used the strips.
The bar model.
Yeah.
Have you ever used a number line model?
No.
That's unbelievable. It's amazing.
Yeah.
And so that's something that I'm going to share with you today. And I just want to go through before The circle model is interesting, but that's the one that can cause the issue.
The trouble.
So I'm just going to go back now, and that's it's actually amazing what you're telling me about where the struggles lie,
Yeah.
and where that learning has to come from. Now, what do you think the reasons for those are? Why do you think that they're coming to you in grade 7 with not that deep understanding of what a fraction is?
Of what the concept of it
Of
is.
a fraction is, yeah.
I'm not sure. I'm not sure where it. I'm not sure because I'm not sure. I haven't taught the lower grades either.
Okay.
So that's a little difficult because I haven't been in
Yes.
that world.
Right. But
taught it
your
in
own
grade 5.
understanding of fractions, okay, even go
Yeah.
back to grade 5, because as teachers, Heather,
Yeah.
we can't help students move forward with their learning if we're not understanding where the lack of understanding is coming from, right?
Yeah.
Have they developed misconceptions? Do we ourselves as teachers have
For sure.
misconceptions and we don't even know, and we are putting them onto our students? Because I know
Yeah.
I've done it.
For
And
sure.
then I've had to say, okay, kids, back up the train, erase. Erase, just we're going to start all over again. So they could be
Yeah.
our misconceptions, or they can be the students' misconceptions. So when you think of yourself teaching fractions over the last couple of years, whether it's grade 5, grade 7,
Yeah.
you think about the students, what's going on, and your own teaching. Do you think you have any misconceptions, or you think they have misconceptions? And if so, what do you think those might be?
Oh my, that's a loaded question. I'm not. I don't.
You're just not sure.
I'm just not sure. So maybe that says too that maybe I don't feel confident enough in it, even
it's
in my
not-
own. I don't know.
Yeah, and it's a difficult concept to put forth to our students. And
Yeah.
you know, with me being out and subbing and being on leave, it's been exciting because I'm working on this with kids as early as kindergarten.
Right. Yeah.
And I've
Yeah.
been deep into it with my grade 3s, and Shauna, you can account for that. And I felt my last year when because I've been learning every year in the last about 3 or 4 years, when I've really started getting on this fraction.
The fraction train.
The fraction train and the excitement of fractions, and
Yeah.
where it really came to last year with my students was unbelievable of what they were understanding about a fraction. So then I'm going to ask you again here too, just before I tell you what a common misconception is.
Yeah.
What is your definition of a fraction?
I would always think of it as a part of a whole.
Okay.
Yeah, I
So-
totally would. I would think of it as like whether I'm thinking of
But what does that part of the whole mean to you then? I'm going to go a
the
little bit
parts
deeper.
that are equal,
Yeah, awesome.
right, in
yeah.
the whole.
Yeah.
So they have to be equal distance, equal size, whatever.
You got it.
Yeah.
You got it, Heather. That's exactly what it is. And where we can get really the misconceptions for students is because when I'm mentoring in a grade 5 and 6 class, and I started in the fall,
Yeah.
and I asked them what is a fraction, and they stumbled, they faltered, and all I got was the shaded parts and the unshaded parts.
For sure.
So that's where the
Yeah.
circle models can be a
Yeah.
real problem, or,
Yeah.
we start with little guys with geometry of folding. But it's easy to fold in halves, and it's easy to fold in, of
Yes.
even numbers, but then how do they fold in thirds?
Yeah.
How do they fold in?
I've tried that.
And this
in
is something
sevenths
actually, yeah.
or ninth, when it's not even, it's
Yes.
difficult.
And this
Yeah.
is something that a grade 4 teacher actually did. She said to a student, okay, where students fold, gave them a strip of paper and said, show me halves. Okay?
Yeah.
So she showed the girl, there was one student who showed her halves, and she said, okay, show me thirds. And the student went like this.
Right. Yeah,
Okay?
because it's 3 pieces.
So, but
For
again,
sure. Yeah.
the idea not understanding that these are not equal parts, those are not thirds.
Right.
And it's not about shaded or unshaded parts. It's about a whole being iterated. There's iterations or copies, and you get that part is repeated over and over and over, meaning that each part is one B, one part of B, which is the whole of how
Right.
many parts
Gotcha.
there
Yeah.
are.
Yeah.
Right?
Yeah.
So that's where the misconception lies. And that's where I know even when I taught fractions years ago, until I read an article that I'm going to share with you, that's how I taught fractions,
Yeah.
is there was just whole shared and shaded and
Yeah.
unshaded parts.
Yeah.
and they were just writing fractions really without the understanding of what a fraction is.
Just counting how many things are colored. And
Yes.
That's it, right?
And
Yeah.
so what they're saying is that our young students, and I read this is what got me on the train, on the fraction train,
Yeah.
is I read this article. I read these articles front to back. I get them, and it's amazing, and I'm always reading. So it's in the 2015 edition, and it's called The Iteration Unit Fraction Knowledge and the French Fry Tasks. And this is absolutely incredible to help kids really understand. And again, Shauna, you can attest to this, working in my room a lot. So the idea is to start with that idea. This is giving them a strip of paper, not starting with circles. Circles are good to add in after,
Yeah.
and all kinds of things, of course, because you want them to have that idea. But idea that this is a whole, okay?
Yeah.
And this whole can be, they put in here that this whole can be a French fry. It can be a chocolate bar. It can be, it doesn't matter what it is,
yeah.
okay? But it's a whole. And you want to share this whole with 2 people, okay? So how's that going to work? Well, of course, they might just start with folding.
Right.
Okay, the idea that depending on what 1/2. Now you want to share it with 3 people. So the idea is they, and I like this in here, and you can start, and younger kids would start with objects actually.
Right. Yeah.
Right, which is that object has to iterate itself, not overlap, not have
Yeah.
gaps, right? And so, this is actually quite right.
Mm-hmm.
So the whole, I can share it with 3 people, and each person would get 1 part out of the 3, but they actually have to count these as whole numbers. It's the magnitude of whole numbers first prior to fractional counting.
Gotcha.
Okay?
Yeah.
So this is actually 1, 2, 3. Then this becomes 1/3, 2/3, 3/3.
Yeah.
The magnitude of whole numbers have to be understood before the magnitude of fractional units, or that unit of fraction.
Right.
Okay?
Yeah.
So that's how the young students start, and sometimes they need that, and then they get to where they don't need that, then they start, right?
Right.
They start doing this.
Yeah.
With my grade 3s, we actually used, in here, okay, you're going to share it with 3, you need to use fingers, and this is really, it really was interesting. So they start, okay, 1, and that's a copy. It's an iteration. This is the iteration. This
Right.
is the piece of the whole, not the tick mark, but the piece of the whole, okay?
Yep.
This part.
Yep.
So they go, okay, well, and they don't use any pencil, not anything, and they're just trying, and they're going, okay, well, that can't be. I've got this left over, so my iteration, my piece, that 1 part, 1/3 has to be a little bit bigger, okay?
Right.
So they go a little bit bigger. And we think this is trivial or too elementary or too simple for our grade 5s, 6s, and 7s, but this is the way I actually started with the grade 5s and 6s.
Yeah.
And then what I saw today back in there, I was amazed with the
Oh,
little
that's
bits
awesome.
and pieces that I saw.
Yeah.
So, okay, that's still. So they have to keep playing with it, and they'll go like this, and
Yeah.
they'll go, okay, well, no, but if that's too long, then I have to be smaller, till they finally get. And I'm just gonna go here. That's the idea, okay?
Yeah.
So then they finally get in where they put in their marks, and
Yeah.
they put in, but even so they can cut this and put an overlap and see, right?
Right.
Because then they start the count of 1/3, 2/3. It's not 1 out of 3. It's not 2 out of 3. It's 1/3, 2/3, 3/3.
Yeah.
Okay. Then they can take another one, and you go, okay, it's the same whole, because you talk about ordering, you talk about counting, you talk about position, and this is the progression of fractional understanding. All those things that you actually have to do, and we'll bring up that in a minute. But you want to share it with 4 people. Well, do you think that size of that iteration, or that 1B has to be greater in size, or then that starts helping them compare,
Right.
because then they start just looking at the denominators and going that 1/4 is greater than 1/3. That's not the case, right?
Yeah.
So, okay, well then I need more pieces, so that has to be smaller in
That's
size.
great. Yeah.
Oh, look at me, I'm pretty good. Okay? I've had enough
You've done
practice
this
about,
before.
I've done this plenty of time, haven't I, Shauna? Okay, so the idea that it needed to be, but they have to work at that, and they will be frustrated at first, they do.
Yeah.
Okay,
To get it that
to get,
right.
and I work on it, and I have kids. They get little teary eyed, but then they get it, and they're just so proud of themselves. It's a productive struggle, And we need
Right.
kids to have productive struggle.
Yeah.
Okay? So that's where we can start, and this needs to be, and they start, okay, and then you take another strip and you say, okay, we'll share it into fifths. What do you think is going to happen?
Right.
You can do halves on top. And they start seeing also what's happening with the size of the iteration. Again, kids will tend to count the tick marks, but it's not the tick marks. It's that is the iteration that copies itself, and
Right.
that's the piece of the part of the whole.
Yeah.
Okay, so that's really, really important. But like you said, they have to count. They have to learn how to count fractional units.
Yeah.
Then they need to learn how to share them and see, and then you get them to start comparing. Another thing that they have to do, and it's on the smart board there, which I did with the grade 5s and 6s today, and it was awesome. They had to position or locate unit fractions in relationship to 0, half, and 1, and that's what you guys have to do as well.
Yeah.
With that understanding.
Yeah.
So that was really interesting too, because I had kids and I loved it because they were connecting, and Shona, I'm just going to come up. And first of all, there were students who, they had to do it on paper first, and then we did this together and they discussed. And they connected the 10, 12s, and 5, 6 are equivalent, and I wanted to see if they got it. And they knew why. To double, and see, that gets, you talked about common denominators, right?
Yeah.
The y. And so they talked about when you can half each numerator and denominator, you can double each numerator and denominator. Okay?
Yeah.
But the idea, I said, well, how do you know that that's 10 12ths and 5 6? Well, if this is the whole, this has to be 6 12ths.
Yeah.
So, and my 10 12ths, and one boy said to me, which was awesome, well, I know that 1 6th and 5 6 is going to give me a whole, because what 5 6 is 5 1/6.
Right.
See, that's another thing too they need to know, Heather, that 10 12ths is 10 1/12. They need to know that each iteration, right? So again, he said, well, 2 12ths and 10 12ths is 1 whole. So I was like, it was just so exciting. And then I had kids come up and we were talking about why the quarter goes here. But I had kids, they were just particular. They were doing those iterations. They needed to be there right exact.
Yeah.
And even I had one boy who he had to put in 3/4 and he had to remove these. He removed those off of there because he said, I have to be exact. Okay?
Good.
And so he removed those and then he put those back, and it was awesome. So then I said, well, with the 7 12ths, why here again? Because this has to be 6 12ths, right? And then even if you think of this as 5 6, well, you have to know that if this whole was 6ths, this is 3 6.
Yeah.
So 4 6 5 6. So they have to. The denominators are what tell me how many iterations I need within the whole.
Right.
And then here too, they can compare. Well, so is 1/4, if I look at this iteration, is 1/4 greater or less than 7 12ths?
Right. Yeah.
Okay? So that's where they're not going to be able to add, subtract, or anything if they can't count fractional units, if they can't compare fractional units. And when you talk about adding, are they having any trouble adding, let's say that we have 6 12ths and 7 12ths. Are they having any trouble?
None.
Okay, but do they know this, Heather? This is what I'm going to ask you. So if this is 6 12ths and I need another 7 12ths, do they actually know, without teaching any improper fractions or mixed fractions, that this is actually 7 12ths, okay? If I need 6 more and then the 7th, right? This is actually 1, and then I have another 1/12, right? Because this is 13 12ths, but that's actually 1 whole and 1 more 1/12.
We break it apart.
Okay.
So that they will know.
Because if you do this again according to the research and what's going on, we don't even have to talk about improper fractions or mixed fractions. They get this understanding by building on.
Yeah.
Okay? Because they can even turn this into all 12ths and say this is 6 12ths, and they're actually making hops. Some of the, right?
Yeah.
This is, 1 more 12th. And they're actually counting out 7 12ths, but they know that 12 12ths have to make the whole.
Right.
It's all about understanding that the 12 1/12ths make the whole, and anything after that is another 1/12. Okay? So then that, they cannot, then you talk about common denominators. Well, then they start understanding if they're adding 5/6, okay? If they're adding 5/6 to 1/4,
Yeah.
they're looking at the wholes, okay? In terms of the wholes, they know that this needs to be 6,
Right.
okay?
Yeah.
And they know that this one needs to be 4ths, okay? But what, they need a common denominator that you can't, I have had kids who would go like this,
Yep. I've seen it.
okay?
Yeah,
But they have to
absolutely.
so they have to make this right. So how do they think? This is actually half on both, right? This is half on both. So what do you think they have to do here? To make these equivalent, to have the same number of
Yeah.
iterations. What do you think they have to do?
On your number line?
Yeah.
I mean?
They have to have the same number. Now they have 3 iterations here and 2 iterations here, or 6 iterations and all and 4 here. What would we have to do within each of these to make sure that both number lines have the same amount of iterations?
I don't even know your question.
Make more, make more.
We
Make
need to
more,
make
yes,
more.
or-
So
yeah.
how many would we divide this into?
To get to your,
Well, each of these would become 4.
yeah,
Each of these would become 4.
right,
Each of these would become what?
6.
6.
Yeah,
And remember, it's iterations, not tick marks. 1, 2, 3, 4. You need okay.
6 and 4. Yeah,
1, 2, 3, 4. So then, how many iterations on each? In each half?
in each half. So one would have 8 and one would have.
No. If you
No,
did,
now they each have 12 there.
yeah, they each have 12, Heather.
Okay.
Right?
Yes.
Which
yes,
then you get a common
Yes.
denominator.
Yes. Yes.
Right? So then you
Yeah.
think, okay, well, if 5, 6 is here, right?
Mhm.
I need to continue to give how many
The
tick
same
marks for
number,
each? The
yeah.
same. So then they can convert this to 12ths or convert this to 12ths and 12ths, so they have a common denominator.
12. Yeah.
Do you see that?
Yeah, I do.
So they actually, the number line model, this
Yeah.
is amazing for kids to be able to understand and do and see. So if we kept going, we shared this into how many again each one?
That one.
4,
is-
right?
Yeah.
So then if we have 4 in each, except we don't need this because we only had 1/4, right?
Right.
So 1, 2, 3, 4, 5, 6. So how many 12ths is that, or how many 12ths? That's kind of what they have to be able
And
to
then
do.
they can just count it, and then they would know. Yeah.
Yeah.
I get you.
Does that make
Yeah,
sense?
it totally does.
But they see that's where the common denominators come in. So that's where they start switching around and they have to be able to do.
And they
Okay.
can do it different ways with a number line rather than having to do.
Well, and that's it too, because even if they have something like, this is another thing too, which if they have something like 3/4 and 4/8,
Yeah.
this is where they have to understand fractions, because they can decompose this. Well, first of
Right.
all, they can
Yeah.
decompose this as 2/4
4
and 2/4.
Yeah.
Okay, so and then they have 3/4.
Right.
Or they can decompose this as 1/4, 1/4, 1/4. This is actually 1/2, which is the same as 1/4 and 1/4.
Yeah.
So you actually have 5/4.
Yeah.
Do you see that?
Yeah.
So, but
Yeah.
if they don't understand
You
fractions,
break those
they have to
apart,
be
yeah.
able to decompose fractional units just like they do whole numbers. And this is kind of what they need to start understanding about common denominators.
Right.
They need to actually visualize it, and they need to be actual to do it and see it.
Yeah. Yeah, no, that's great. Yeah, that's great.
So just a little bit, and I'm moving you a little bit forward into
Yeah.
more of that grade 7, but they have to actually be able to do all
That's
of
step
this stuff.
one before
This
you
is
move.
step
yeah.
1 before we
Yeah.
even move, because if they don't have that basic foundation of, as you said, of counting units, fraction units,
Yeah.
then comparing fraction units with like denominators, looking at relationships of fractions of where they would be located in terms of 0, 1/2, and a whole,
Right.
right?
Yeah.
And of course, depending on the size of the whole, 1/3 may not be equivalent. 1/3 of a pizza may not be equivalent to 1/3 of a chocolate bar,
Right.
because
Yeah.
that depends on the size of the whole.
Right.
Then they need to get into all of that as
Right.
well, right? So
Yeah.
those are the things
Yeah.
that need to be done.
Mhm.
And Shauna, can we bring up that fraction progression? Are we able to do that? Sorry, she has to multitask here. We're just about coming to an end here. I took a picture of the work that I was doing with the students today, which was awesome. So in a research, and all the research and videos, and I've been watching of Christina Tondevold, Graham Fletcher, reading various articles. There's many articles. The one I just shared with you is just one of many that I've read on fractions within the NCTM magazines. But this is a summary of fraction progression. And this is something that I'm going to be doing fraction tutorials based on this progression, that will be for sale and up on my website, along with this PDF early February, we're hoping, right, Shauna? End of January or early February. And if we just kind of go down, they talk about the stages of counting, Heather.
Yeah.
They have to be able to count by, it's talked about whole numbers. If they don't have an understanding of whole numbers, they're not going to understand fractions.
Right.
So there we go, we were talking about that. And they said that this builds understanding of equivalence without the need for algorithms or improper fractions.
Yeah.
If they're learning how to do that count.
Yeah.
Then they compare and they equivalence, okay? So again, they have to have that count, and we know as we move to the left on a number line, numbers get less. We move to the right, numbers get greater. That doesn't change for fractional units either,
Yeah.
okay? And then they talk about, so I give a ton of examples, and then it can build on equivalence. 2/4 is the same as 4/8, 1/4 is the same as 2/8,
Yeah.
right? When you're working, so they get that understanding. But of course, 1/8 is smaller in size, and they see that it's half. So they start learning about that as well, not just being told.
Yeah.
Okay? And that, yeah. And then they get into,
Yep, sorry.
whoa.
Fingers
Then they
went
get
too
into addition. But again, if they don't understand addition with whole numbers, they're not going to understand addition with fractional units. And again, they have to understand that 11 copies of 1/10, or 11/10 is 11 copies of 1/10.
Right.
Right? So in 12/10 you get 23/10. But if we know 10/10 make a whole, then they know that becomes 2 wholes and 3/10.
Right.
But they have to understand what that whole is made from. Okay?
Mhm.
Okay, we can just scroll down there. And then they get into, and then I give examples. So, and parents, if you're listening to, this is accessible to parents to help your kids, and the tutorials can even be for students, can't they, Shauna? Subtraction, the same thing. They have to understand that 1 and 1/6 is the same as 7/6 before they can take away 5/6.
Yeah.
So they have to, and again, it's about decomposing, right? And that's
Yeah.
the one way to do that with whole numbers. Or another way that I showed you through this, right?
Yeah.
Decomposing through that way to add and subtract, okay? And then we get into the multiplication, which, well, if can't add and subtract, they can't multiply. But do they know that 3 times 1/3 is actually 3 groups of 1/3?
Right.
Do they actually know that they're doing that? Or are they learning the algorithm as I'm just going to go 3 and 3/3? But they don't really understand what that means. Whether it's through visual representation or words or through a picture, right? If I
Yeah.
have a 1/2 times a 1/3, I'm taking, my half, there's my half, but then I'm having my thirds. Do they actually understand what really is going on? Can they really share their understanding through a diagram?
Right. Yeah.
So again, or just doing the algorithm of I'm going to multiply. So, okay. and then of course to divide, do they, again, are they connecting it to, again, multiplication and division, are they connecting it to whole numbers? When you multiply, you have the number of groups and the number in each group, but you don't know the sum. That's the
Right.
same as 3 3/3. I've got three
Right.
apples, I'm sharing them into thirds. Each apple's going to be shared into thirds. Can they contextualize and give a story? Do they really understand what that means?
Right.
Okay? And the same with dividing. If I have one whole divided by 1/3, that means that I am taking a whole and I'm sharing it into thirds, not just I'm gonna do the invert and multiply, but they don't even
Right.
understand why.
Yeah.
They don't understand
Here's a
why.
rule. Do the rule.
There's a rule,
Yeah.
right? So
Yeah.
that's the thing that they have to be able to do. And then when they get to 2.5 divided by 1/3, and also, do they know that this is the dividend, and that's the divisor, or did they know that we're finding out how many times the dividend goes into the divisor
Mm-hmm.
to get the quotient? It's the
Right.
same as whole numbers.
Right.
So when I have how many 1/1/3 go into 2/1/4, but I have to be able to change that. I don't want to work with wholes. It's kind of hard to work with wholes, so it's good to be able to change that. 1/3 is the same as 4/3. 2 1/4, right? So it's 9/4 divided by 4/3. And then this becomes, again, you'd really have to look at this, but this is a visual model representing that. I'm taking my 9/4 and each one has to be divided into 3. That's why I get 27. When I look at my 4/3, that's actually giving me 16 parts, and I have to share these into 4s and 3s. That's what that means. I couldn't put my lines.
Oh, yeah.
So that's where I get, if we can just scroll, Shauna, if that's where I get the 1 whole and the 11/16. And I explained that in there, and that would have to get in there a lot more. Okay?
Yeah.
And if we can just scroll, continue to scroll. And I explained that, and I actually worked it out myself. And I tell you, I worked it out, and I was struggling for a minute. I was going, why is that denominator 16? But it was 16 because I had to make that part fair, just like we did
Just
here.
like, yeah.
So where it ended up, and I tell you, it took me, and this is not, it's right here. And you asked my friend, because I took it, I met her for coffee, and I said, I don't understand why the denominator is 16. And she goes, Darlene, I know you're going to work it out. I was like up, and I had my paper in bed, and I had to figure out why. But see, we just tell them to invert and multiply.
Yep.
But I needed to figure out why that was 27/16. I knew why the 27 was there. I couldn't figure out why the 16 was there.
Yeah.
And then it was 1 whole. So that's where that leads to.
Right.
So I'm
The whole
hoping
concept
the
understanding.
whole concept, and that's exactly, Heather, you hit the
Yep.
nail on the head. When we're teaching the concept, the understanding of the concept. Rules are great, but do they understand why they're using the rules?
Yeah.
So if we don't have the underlying understanding of the concept, rules make no sense, and they're just flustered, and they have a hard time with it.
Mm-hmm. Yeah.
So I'm hoping
Yeah.
that was helpful.
That was very helpful.
We're a little bit over time because I could just go on and on. It's exciting, but I appreciate you sharing that, and I hope that you take it back and you ponder and you think
For sure.
and think about things if kids are struggling with things. I know you talked about little things, but even share
Yeah.
with colleagues, and
Yeah.
like I said, I'll let you know when those tutorials are ready, and we will go from there.
Awesome.
Okay, well, thanks for
Awesome.
joining me in
Thanks,
tonight,
Heather.
You're welcome.
and thanks everybody.
Thanks everyone
Hope
for
you
joining
enjoyed it.
us.